All right, dear friends and dear students. Today I'll be talking about the very important topic in basic quantum physics, that is eigenfunction and eigenvalue. And to start with, I would like to write down the total energy of a bound system. Suppose E is the total energy. Now this will be sum of kinetic energy and potential energy. I'm taking only one coordinate. And as we have had previously talked about operators, mainly we talked about energy operator and momentum operator. We can replace this total energy in terms of its operators. So for E, I will use an operator E cap, and for P it will be P cap divided by 2m plus V as its so if I proceed, I will write E cap. I will replace this this energy operator by I h bar partial derivative with respect to time is equal to 1 by 2m h bar by I. Then we can take the total derivative here because we are assuming only one coordinate. So it is d2 by dx2, right, plus v of x. Now we are going to use a wave function here. So it is I h bar, the partial derivative of time psi is it is minus h bar square by 2m. This is d2 psi upon dx2 plus v of x and psi. Now all of you know that this is time dependent Schrodinger's wave equation. And you can see, if I proceed the same thing, now if we get this this minus h bar square by 2m d2 upon dx2 plus v. Now this bracketed this bracketed term is also called as Hamiltonian. So I can replace this whole thing by an operator, by a Hamiltonian operator. And I can replace this back to energy operator. E cap psi is h psi. So the equation that we have obtained here is again Schrodinger's time-dependent equation, in which E cap is your energy operator and H cap is the Hamiltonian operator, and Hamiltonian operator is in the brackets. It is basically the replica of classical mechanics in quantum mechanics for Hamiltonian. So you operate a wave function and you expect a result out of it. And if I take some general operator, say G, I will take a general dynamical variable, G. such that this G psi gives me G dash psi. It's equal to some G dash psi. I will replace this, this dynamical variable G by its operator. If I replace this G by its operator, and evaluate the thing, what I will obtain is something Gn psi. Now, for a problem that is bound in nature, this Gn has discrete values. First of all, this Gn has to be a real number. And secondly, the values that are evaluated by operating this psi using this operator of this dynamical variable G, these values that we obtain for those bound problems are quantized values. And the values that we are going to assign for G, these values are referred as eigenvalues. So these values are referred as eigenvalues. And the wave functions that are associated to these discrete values, the wave functions that are associated to these values that are obtained, these functions, these wave functions that are associated with these eigenvalues, these are called as eigenfunctions. We call them as eigenfunctions. Now let us take an example. Suppose we have a wave function psi is equal to e to the power of alpha x. And we have to operate this wave function by an operator d2 by dx2. What will be the eigenvalues of this problem? So the solution is quite simple. So your dynamical variable has been replaced by an operator. You have an operator here. You will operate this operator on the wave function, and you should expect a real number to come out of it. The real number that will come out of it will be the eigenvalue. So the problem is quite simple. So I will write here, so what's going to happen here, I'll call it G cap. So G cap is psi. So instead of G cap, I'm going to use the double derivative. So instead of psi, I'm going to use e to the power of alpha. So when you will take the double derivative of this problem, what we will get? We will get alpha squared e to the power of alpha x. So the value that will be calculated for this alpha squared, that value will be a positive value and it will be a discrete value. This value that we have obtained here is the eigenvalue. So alpha squared is eigenvalue. This is what eigenvalue means, and the very associated wave function with those eigenvalues, we call them as eigenfunctions.